And the experts and the information just continue here at the Application Architecture Summit. This is the session for Temenos, now an owner of a very well-known platform in low-code, Coney. And with us, we have the Vice President of Product from Temenos, Matt Trevathan. Matt, I want to welcome you to the show.
Thanks, fans.
You know, we're really glad to have Matt with us this morning. He manages the Quantum DevOps and low-code platform for Temenos Coney. He has more than 20 years experience in building out complex architectures and transforming businesses with technology. And in fact, his combined background in consulting, technology, and in fact, hands-on invention really open up a lot of efficiencies and innovation. And on the invention side, Matt actually holds approximately 200 patents in the digital space. So we're really glad to have him with us this morning. His session is entitled Playbook for Modern Architecture. And in it, he is really going to help calm a lot of the fears and anxieties that many folks in the development and app architecture space probably have. We know many of you are looking to modernize your legacy apps and business processes, but often the solutions you find can require a ton of custom coding and even complex integration. Matt is going to show us how the low-code integration platform is really responding to a lot of those needs, taking legacy assets and moving them into the future for some really agile app projects. And just a quick reminder before I hand it to Matt, you can download his slides, and I think what you see them, you'll really want to do though, just hit the big red button under the view screen. You'll get those right away. Matt and his team have also assembled for us some terrific PDF assets and links directly to the Temenos website. And we love to have you connect with our experts. So in this case, to connect with Matt, just type in the submit a question box. So with all that, Matt, let me turn to you and tell us about a playbook for a modern application architecture.
Thanks, Vance. So we've all been here. I used to work in services and do consulting, and a lot of times we come in and the first iteration of services came out and people started doing XML, and then it moved into SOA with SOAP services, and we had these big heavyweight services. And then as we looked forward, we needed lighter weight services on the back end so that we could start to expose them to these things called mobile devices all of a sudden. And everyone starts using mobile devices. So now I have some services that are written RESTfully. I have other services that are written in SOAP, some in XML, some in BAPI. At the end of the day, I've got all these backends, and then there's an explosion happening on the front end of our applications where people are wanting to do more apps. They're wanting more features. They're pushing a lot more pipeline, yet we can't meet that need. So what I really want to go over today are three things: is really look at the legacy of where apps have come from and where our problems are, and looking at building that foundation of apps, how to reuse, how to deliver and optimize building a modern architecture. And then at the end of it, I'm going to have just a summary slide that really shows what that modern architecture should look like, and we're going to build it along the way. Wow. $1.2 trillion are being spent on digital transformation. That's a lot of money. Most of the people here are probably thinking the same thing. I'm here because I'm one of the guys that's about to spend some of that $1.2 trillion, or I'm in the middle of spending that $1.2 trillion, and I've run into some roadblocks. One of those roadblocks is when you look at the end of the day, we have 75% of our organizations that are being disrupted because of skills gaps. And a lot of these skills gaps come from technology. We have created things that used to require heavy developers, and as we've moved more and more towards lighter weight services, now we're looking at being able to enable what we call the citizen developer or the low-code developer. And along that way, whether you're a true developer or you're a low-code developer, we have to meet that skills gap head-on in a more modern architecture. Great number here, 1 million. 50% of companies right now are behind on their digital transformation. 50% of the companies in the S&P 500 will drop out of the S&P 500 in the next 10 years. Why? Because they can't transform. And part of the problem here is this number right here, this 1 million number. We have so many needs for jobs. 1 million is a big number. You see it on the screen, and really what it represents is the opportunities in the United States for developers. By the end of 2020, there are going to be 1 million open seats for development jobs. Now, the problem here is we can't meet this need. If you look at digital transformation right now, to the gap to meet this need, most companies, 50% of them are behind on digital transformation. If you look at S&P 500, those who are going to fail in digital transformation are going to end up falling out of the S&P 500. Right now, they're projecting in the next 10 years, companies that do not succeed in digital transformation, 50% of them will fall out of the S&P 500. So this creates a lot of opportunity for those of us that can transform, but this also creates a lot of havoc if you're one of the guys that are inside of that transformation. So what I'm going to take you through is where I view how digital transformation can be successful, kind of building from the ground up. The first thing we're going to focus on is the foundation. Now, integration is definitely a huge problem in how we expose services. 50 to 75% of our cost and time come from building out our integration, taking these old legacy systems and modernizing them. So anytime that I have to go integrate into a soap service, I can remember years ago working with clients and having to go back into a soap system, get the contract changes slightly, going back and telling these guys the contract changed. And to be honest with you, everything would be done on the front end before the back end was ever integrated, because there was so much work to be done on the back end. Any of us who've done integration work know at the end of the day, building an app, that is where most of the time is consumed, and we have to make this easier. So the first thing I want to look at is, if you look at the bottom of the screen, you can see these line of business services from your ESB, JSON, XML, SOAP, databases. We need an easy way to present those up to our channels, whether our channels are phones, tablets, desktop, wearables, chatbots. I really don't care, but I need to get those services so that they're easily ingestible by my channels up top. Some of the things that we focus on when we think about this are integration services, taking those back-end services, creating a standardized way of communicating to them, identity management, managing identities to these back-end services in a safe and secure way. And then we think about some other things like monitoring those services or getting those services so they're usable by developers. And what I mean by this is usually API management. I'm having a portal where I can go and find these services, I can learn about these services, and I can use these services. So part of exposing APIs and making them easy is creating a place that we can find them. And it's great if I can create an API portal where someone can go to, they can look up various APIs, select the APIs they want to use, and easily start integrating with those APIs. Part of doing that is generating documentation for your APIs. And if your integration engine and your API management engine can automatically generate API documentation, that's great. We do that at Coney with our Coney Fabric. We create a ability to make a portal, and we also automatically generate the APIs so that when a user comes into the developer portal for their APIs, they see the APIs that they want to use. They can come down, they can look at the various aspects of the API. They can even test the API via the documentation before they ever start using it inside of their development environment. Okay, next I want to talk about reuse. So we've built this solid layer on the bottom, and we've built up our services, our integration services, our orchestration services. We're going to put an API management layer on top of that. Now I need to get my applications developed. And when we think about applications today, again, we don't want to recreate the wheel. Over and over again, over the years, I've seen people, and the login screen is always an easy target. Every project that they go on, they talk to the same backend for authentication. They have almost the same look and feel, yet we recreate the wheel over and over again. There's not time for that anymore. That takes a lot of developer expertise, and we're trying to move away from that some. The other thing is it's just reinventing the wheel from a time-consuming point of view. So we don't want to be recreating the wheel. We want to be innovating because our backlog is continually growing. So when you think about even low code, think about reusing components, not just components on the front end, but components that touch those back-end services. So they're reusable from top to bottom. So what does that mean? And here's some example components that we commonly think of. Again, the login component. I need to be able to log in. Well, there's a piece of UI that's associated with that. There's some configuration because maybe I want the screen to look a little different for one app versus the other, but the real overall template of my login stays the same. I need to connect to something on the back end, like an identity service. I may even have an app data model that's associated with it to make it easy to drop that component right into an application and start using it immediately. In the case of a bank, I have my accounts, and I have a lot of apps that use my accounts page. I could simply create that form, create the underlying logic, and simply pull that into my app anytime that I want to use it. But we also have to think about reusability across channels. When mobility started, we were kind of disparate. We had mobile web and we had traditional desktop web. Now we've got mobile, we've got tablet, we've got desktop web, we've got responsive, we have something coming up called progressive web apps. And that's where I'm taking some of the best of native and combining it with the best of responsive and really creating app experiences that are almost native looking, but give us that power of being on the web. And I'll go over that in a second. But the important thing here is when we're building reusable components, we need to think not just about a single channel anymore. We need to think across channels. And that brings us to delivery. Now, I'm going to talk about this progressive web app thing. If you're on here, you're probably, again, familiar or you've heard progressive web apps. And they aren't the silver bullet. They're not going to kill everything out there for you. But what they do is they do combine, for a majority of our apps, what we need to get the job done. So what do I mean by that? Well, we have native apps first, and those really gave us a lot of functionality. It let us go offline. It gave us push notifications. We could install it from the App Store and put it on our home screen, and we get a very native full screen experience. And then some guys came along and they created something called PhoneGap because they said, that's great, but there's a lot of things we can't do that are just simple native things, like use the camera, find a person's location, push something to their device. So as HTML5 evolved and the spec happened, those were things that people made sure were into that spec. So that today, when we look at things like PhoneGap, or we even look at native apps, there are times when we don't need to do native, and there are times we don't need to do PhoneGap. There are times when augmenting a responsive app so that we can use functions offline or push or use my camera and get that full screen experience, install it on my home screen. That's what progressive apps do. They take the best of that native app, they combine it with the best of responsive web, so I can literally put a native looking app onto my home screen with a fraction of the size of my traditional native app. I don't have to go to the App Store to get it. I don't need to worry about updating, because anytime they come in and they're online, it's going to automatically update. And by the way, downloading is optional. So for a lot of people, I tell them, hey, look, if like we can in Coney, you can build a native app and you can build a progressive web app. If people still want to go to the App Store, they still want that native experience, you have that ability. And if people want to do progressive web apps because they hit the site, they don't need to go to the App Store, you can do that too. Companies are moving in this direction. Uber is a great example. You can download the Uber app, but you could also go to m.uber.com and you can actually download their progressive web app directly to your device. Is it the same app? It has the same functionality. They look similar, and it'll do what you need it to do. The biggest difference for me is the size. That progressive web app is literally kilobytes versus 60, 70 megabytes that you need to carry on your device for a native app. So this leads us to thinking, hey, progressive web apps aren't the silver bullet, but they're going to be able to do a lot of things in the enterprise for us that we don't need all of this talking down to native SDKs to get done. So that's another spot where we can come in at Coney with our visualizer product. That's one of the sweet spots with Coney is not only can we come in and build a native app, but we can take our components like what I'm doing here, and we can build a responsive app. And instead of quote unquote building it, at first I'm just assembling it. I need a login page. So I'm dragging things that are common to my login page. A lot of our pages have a locate us, a contact us, a privacy policy. And as you can see, I'm setting breakpoints here so that no matter how you look at it through the breakpoints, it kind of looks like the same functionality in the app. And this is the beauty of component reuse. I've just built a login screen, and that login screen looks different across my channels, but the way I built it was through assembly, not through sheerly building every piece of this screen. Now, what I'm going to show you on the left and what I'm going to show you on the right, I just transitioned screens very quickly because I want to go over a concept. What you're going to see me do on the left on my desktop is the same thing you're going to see me be able to do on the right on my mobile experience. The key here is it's the same code base. It's the same app. I can actually, from a progressive web standpoint, take this app and load it, if I'm using Chrome, onto my desktop, just like over on the right, I'm running a native looking app. And as you can see, it's still responsive if I'm using it on the desktop. So I'm taking something that I'd normally disperse across 3 channels using responsive and progressive web apps, giving you that ability to take things offline, to have that native app look and feel, but also to be able to use it across all of these channels very, very quickly from a single code base. Finally, we need to talk about how do we optimize this experience. So the first thing I did was built a foundation of services. I standardized my services. The second thing is I started to look at how I can reuse components, not just the user experience, but the business logic, maybe even the connectivity into the back end. I've seen how I can deliver those, not just from what we think about here at Coney with just mobile, native, tablet, and web, but the new concept of progressive web. Now I want to optimize how I deliver. And this is what brings up this final layer to the right, and this is DevOps. If your company isn't putting things in source and automatically building things and automatically testing things, you're wasting cycles. If you're thinking, how do I get things out faster? Get your testers out of the process of constantly and manually finding bugs and get them into writing scripts to help you create consistency so that they can still go out and find other bugs, but they're always starting from a base of stability. We should think about also building every time we commit code. This leads to this quote. Martin Fowler, who is one of, I would say, the fathers of modern DevOps, says this: continuous integration doesn't get rid of bugs, but it does make them dramatically easier to find and to remove. This is an important statement here, because really what he's saying is we as teams of developers shouldn't wait to do a nightly build. Every time we commit code into our repository and push that code up to our repository, we should be building that. I'm a firm believer in this, just like Martin Fowler is. So what does that mean in our world? It means when a user checks in a project, let's say in GitHub, that project should do a couple of things. I should be able to schedule a build, or I should be able to automatically build it. Now, depending where you are in your journey of DevOps, depends on what you're going to be doing here. For some people, they're going to put the framework in for building, but the first couple times they do it, they want to kick off a manual build. Or maybe they've got scheduled builds that they put into the scheduler and they're only nightly, but they want to kick off a build during the day. But really where you want to be is continuous. Every time we're pushing code, it's building. So whether you have a Mac and you're building native, or you're building Android native, or you're building a web app, you want those to kick off those builds and build those channels for you automatically. When it's done, we look at informing the user, because this is one of the things that if you were a build master, you used to have to do. Hey guys, everybody go test your stuff. The build is done. And that poor guy, who's probably highly experienced, waits for everyone to tell him what's wrong. He runs the build again. He goes and finds everybody. He tells everyone what's wrong again. And so is the process. That manual process just slows things down. And let's face it, we're taking an experienced resource and we're dedicating them to doing something that we could automate. And that's part of the process here, is taking that skilled resource and taking them out of the mundane and letting them create. We should also think about testing. Now, in this slide, I'm going up to AWS Device Farm so I can go against live devices. But even in a responsive and progressive web app, I should be thinking, how do I test this? Every time that I do a build, what should I be doing? I should be testing. And that's so important, because if something does go wrong and testing becomes part of this, your testers shift left, they get involved earlier, but also when you find bugs, you're finding them earlier. I call it the needle in the haystack concept. If I put a needle down on the ground and I look and I can see that needle, I can pick it up. Now I start to throw a little bit of hay. Let's say only build once a day, the needle becomes harder to find. I wait for a week, I have a big haystack and I have one or more needles. For those of us who have been in the industry for years, we know the longer you wait, it's not only the harder it is to find those bugs, in my opinion, but you don't know how many bugs that you've got. So being able to build and test every time you push code lets you find those bugs earlier, and the cost of finding those bugs goes down. At the end of the day, just like with our build, instead of the tester having to send out an email, we automatically send out an email to let people know, hey, you just did a good job, everything passed, we're good to go, or we had a bug over here on this test case, go check it out. And when you're done, of course, deploy that to the App Store. So from a Coney perspective, this is what it looks like. So I have a piece of code. I'm going to check in my project. I just added a new identity connector. I'm going to check it into Git. And then I'm going to go into what we call App Factory. That's our DevOps mechanism. And I'll click my Environments tab here. I'll go into my App Factory. Now, it looks a lot like Jenkins. For those of y'all who are familiar with Jenkins, that's because under the covers for us, it's Jenkins. And we're going to build the app. So this time, I'm going to manually build the app. And you can see I have various things that I can fill out. I have a whole ton of different channels that I can build for. I can also select different release mechanisms. I can automatically sign these things. And I can publish my web app right in as part of the build process and run my desktop web test or run my device web test with a few clicks of a button. So I'm going to hit rebuild here. And it's off and building. Now, when this is done, just like what I said in the diagram, it's going to send us an email with the build results. It will also send us an email with the test results. Now, don't worry. It says 4 minutes, 28 seconds. I did speed this up for the sanity of everybody on this call so we can see what happens at the end of the day. We run our build, we run our test, outcome our test results, complete with a video of where it happened, but also I can drill down into any of my test results and I can take a look at an actual test report, which you're going to see here, that shows me everything that's happening in terms of my test cases. Here are the suites I ran. I had a failure. It tells me where it failed. So as a developer, I become self-enabled. Where before I would do the build, I'd call up testing and I'd say, testing, y'all need to start testing. Now, for those of us who work late nights, we work until 3 in the morning, we check in our code. The poor guy who's a tester is getting up at 7 in the morning and he's testing our code. There is this gap between 3 and 7, a 4-hour gap before we even start testing. But by automatically testing, I know immediately after the build whether I have a problem or not. So I don't need to engage the tester for that first round of testing. He knows it's good, I know it's good, and we've saved a lot of time. So we should also think about analytics. An important part of DevOps is thinking, how do I take and understand what's going on with my applications, with my APIs? Who's using them? At what rate are they being used? Do I have some spots where my app is crashing or I'm getting slow responses? We need to be thinking as developers and as operators of being able to monitor these proactively and be able to project when we're going to need more and to scale more rather than look retrospectively and go, oh, we just had an app crash, or seeing inside of a app store that someone's given us a bad review when everything looks like a green light to us, but it's not. This brings up another thing that's called synthetic testing and production monitoring. I'm a big advocate of not just taking reports, but actually taking a live application and once an hour, once every 30 minutes, running a key set of test cases against the whole application. So you're not just hitting the APIs and the back end, but you're actually hitting the application front to back to make sure everything's running. So if you think about what we call the CAM strategy, culture, automate, measure, share, I'm really focused today on automation and measurement, because these things are very, very important as you start to go through this process of doing a digital transformation, making sure that you have the things to share. And that's really what I'm leaning at here is saying, look, you can't share if you don't know what to share. And reports and analytics and monitoring help you do that. All right. So before I had a line of services down at the bottom, you notice I've replaced those with cloud services. This is kind of that final piece of the modern architecture. If you're doing things on old iron inside of your facilities, you're wasting time. It takes time to put that iron in place. It takes time to talk to your IT staff. It takes time to get stuff installed. You should be doing, whether it's a private cloud or a public cloud, you need to be looking at investing in a cloud-based service because it keeps you with high availability, auto scaling. You get another layer of monitoring on top of that. If you're using something like AWS or Microsoft Azure, you get multi-regional support. So all in all, you're going to get all of the things that you need very, very quickly, again, to build that foundation up. So I have my integration services, I have my app, I have the scalability down at the bottom, and I've taken something that takes a long time in a traditional sense to provision and shorten that provisioning process using the cloud. I combine that with using reusable assets and DevOps, and I really have a complete looking architecture. So here are a few key takeaways. I harped very early on a strong foundation for apps. It does start with a strong foundation of services. You need to standardize those services. I didn't go a lot into identity today, but identity is a service, and all of these services, whether it's identity, whether it's your integration services, you need to be able to easily expose those. You need to be able to easily orchestrate those, do light workflows, all in a back-end application service like API management. You need to be able to be flexible and scale. And that really comes down to cloud, and that comes down to low code. And if you think about that flexibility to scale, there is the infrastructure that scales, but there's also scaling your developers. We can't keep reinventing the wheel to meet our needs. We need to start using things that are reusable, and we should start assembling more than we're building. There's always going to be a need to build, but assembling is a whole lot faster and a whole lot easier. And 9 times out of 10, it meets the needs of our end consumer. We got to stop building apps from the ground up. We need to think about that reuse. And at the end of the day, anything that we look at that is mundane, is reproducible, we should automate, automate, automate. We should be automating our testing. We should be automating our builds. We should be automating some of our monitoring. These are things that you don't need a person always watching, and you have inefficiencies in dedicating a resource to that, but you also have inefficiencies in those other people waiting on them that we don't always think about. And when it comes to things like bugs, you have inefficiency in finding bugs. So the more we can get lean, the more we can automate, the faster that you're going to be able to transform, and the more freedom that your citizen developers will have to innovate. Okay, at this point, I'm going to hand it off, and thank you everybody for attending this seminar today.
Matt, thanks very much. A really great session. And I really liked how you tackled the issue of application architecture for so many of our attendees here, both the hands-on developer, the architect, of course, and even the lesser skilled or the citizen user. Really great session.
Great. Thanks, Vance. I was very excited to give this.
Fantastic, fantastic. You know, Matt, so many different features that you talked about, and it really did resound well with the audience here. I wonder, could you give us a quick review of some of the most popular, let's call them reusable components or services that you're seeing?
Well, the login component is always popular. Everyone needs a login. I see a lot of needs for things like charts, and charting widgets are also very popular. And then we get some things that are very industry specific. I know at Coney, we've worked on some field service forms and components that we can expose as either micro apps or as a full-blown application. They really provide those building blocks that a lot of the field service guys need. And something that gets lost in this, Vance, is not just creating a component, but we provide a marketplace, both public and private marketplaces, that people can find these components. So if you think about, I want to go out and see what Coney's produced, that's easy. You go to our marketplace. But also, if I'm a company and I want to develop my own assets and components and be able to share those easily to our end users, you can do that with our marketplace. You mark them as private. They're only available to your account. And inside our IDE visualizer, you can actually pull those components straight out of the marketplace and start using them in the IDE immediately.
Oh, fantastic. Fantastic. Another popular topic here, Matt, you won't be surprised by this, is APIs. A lot of our guys have been using them for years. Your attention to the API lifecycle management, not just for the ops person, but the developer with, I guess, what I would call API discovery really was great topic. One of the questions here says, can the speaker talk a bit about how the functionality in the Coney platform helps better extend legacy assets, whether they be older apps or even data warehouse?
It's a great question. I had a short amount of time to go over a whole slew of information for everybody, but we have these data connectors that we have that are built to talk to backends and extract that data out and make it easy to make those RESTful services. So we've got a set that are pre-configured with what we call Coney Fabric. That's our middleware piece and our API management piece. So you could go back and use SOAP or XML or SAP very, very quickly. But let's say you have something that's legacy that we don't support. You can also create a custom adapter to pull data out of a custom system and put it in. And we even have more modern adapters all the way to Google Sheets. So if you wanted to build a real quick app, you want to use Google Sheets, we actually have adapters for that too. So adapters really do extend the life of what we're doing on the back end by making them easy to expose as APIs on the front end. Our fabric makes it so that I can literally select items from my response and make those tailored as part of my API. So I pull something from the back end, I say, oh, I want to take that particular piece of data and expose it to the front end. So I'm not writing any code to do this. This is all driven by mapping and by wizards.
This is fantastic, fantastic. Another topic here, Matt, that I've got in front of me here is UI. You talked a lot about mobile and omnichannel and PWA. Here's a question about progressive web apps. What types of apps are best candidates for PWA, and could we use PWA for just about any app?
If you are an enterprise and you don't want to have to put it into Apple's App Store, you don't want to have to put it into Google's App Store, you don't want to have to necessarily keep an enterprise app store, PWAs are great if all you're doing is using some of the basic things the phone provides, location, push, camera. These are also available, your accelerometer. So if you want to think inside that box of what are the base things we think about over almost all of our phones, PWA does a pretty good job of supporting it.
Oh, excellent, excellent. So that really does lead to the last topic here, Matt, and that is this whole issue of on-prem, cloud, and hybrid architecture. You mentioned a lot of the virtues of the cloud in your closing remarks. Give us an overview of Coney's approach toward helping folks that have legacy on-premise apps and data, and yet they know they need to move to the cloud. Where does Coney run, and how does Coney help folks deliver on many flavors of their app?
Can I say all of the above and make this really quick? Seriously, we are available on premise. So if you're not ready for the cloud, you lose that scaling. You really got to think when you're on premise how you're going to scale. So we do give you Dockerized containers. We can deploy with Docker. We can deploy with a full on-premise deployment. We do hybrid. We have clients that part of their stuff is in the cloud and part of it we connect to their enterprise backend system. So Coney itself is in the cloud. The enterprise backend systems are not, and we just connect over a VPN to VPN connection or AWS Direct Connect or some other method like that to talk to those backend systems. So we're pretty flexible on how we can deploy Coney to meet our clients' needs.
Fantastic. And you mentioned Docker there just at the end, Matt. So I would assume that even though we've talked a lot about legacy modernization in this presentation today, you're a very Kubernetes-friendly platform.
Oh, absolutely. In fact, under the covers, when we deploy to Microsoft Azure, we use Kubernetes and Docker, and it makes our deployments very, very easy. And that goes back to thinking about deploying at scale. So whether you're deploying internally in your own private cloud or you're deploying publicly, you need a way to quickly do that. And we leverage Kubernetes and Docker to do just that.
Super. Matt, I see time is almost up, but before we close, so many questions here about the technology and the capabilities of the quantum platform, but certainly it's been in the news that Coney was acquired by Temenos over in Europe, and I think a lot of folks would like to get a sense of what you're seeing after the acquisition and what the impact on folks that might be using or considering Coney would be from that acquisition.
Awesome. Well, the first thing is quantum's not going anywhere. It's the basis for what we build everything else on, including our DBX applications, our banking apps. In fact, Temenos is investing more money in quantum, and they really do see the value of bringing quantum in from a cross-industry perspective because there's innovation that happens outside of banking, and we're able to capture that into our platform and send it to our banking clients. So Quantum is definitely going to receive a lot more attention. We're actually expanding our teams to meet that demand.
Well, in fact, just as from an outside looking in, Matt, I would suggest that to some extent the advances that you have done with Quantum was one of the reasons that you were so appealing to Temenos in the first place.
Oh, absolutely. They saw the value. And that's kind of what I tried to allude to in the answer to my question there is the value of Coney is really Quantum at the bottom of the stack being our foundation.
Fantastic. Fantastic. So with that, Matt, let's talk about how folks can go hands-on or go deeper with the Quantum platform. I know that you mentioned that you have a cloud option, but I know that the Quantum platform has been available for quite some time in different forms. How would you recommend folks go hands-on and maybe take a trial on their own?
So everybody go to Coney.com and sign up for a free trial of our community edition of Coney Fabric, which is the integration layer of Quantum, and you'll also be able to download for free Visualizer, and you'll be able to use the community edition of Fabric and Visualizer free forever and take it for a spin.
Fantastic, fantastic. Matt Trevathan, Vice President of Product for Temenos, which is now the proud owner of the Coney Quantum technology. Thanks very much for a great session, and especially for the demos to put things in a real-world perspective, as well as some great Q&A. Appreciate it.
Thank you, everybody.
It was our pleasure, Matt, our pleasure. And just a quick reminder, Matt mentioned many resources. Some of them are right here in the breakout room, right on the view screen, including that big red button to get Matt's slides, as well as that click to the community edition. And those are all available to you right now. As you can see, in the wake of the Temenos acquisition, a lot going on at Coney with the Quantum platform. So here is a slide that will take you directly to the website, and you can get more resources there. Thanks again, everyone.